In this video, I'm going to be covering some of the most important intermediate level React hooks. I'm going to be covering useContext, useRef, useReducer, useLayoutEffect, and also talking about how you can create custom hooks. Now, if you're not familiar with some of the basic hooks like useState and useEffect, I highly recommend checking out the first video in this kind of series where I cover those hooks and the basic rules of hooks. It'll be linked down in the description below. Welcome back to WebDevSimplified. My name's Kyle, and my job is to simplify the web for you so you can start building your dream project sooner. And to get started, we first kind of need to explain the starting code that we have here because it's actually rather complicated. You can see here that we have three different pieces of state. We have a loading state, which is true or false. We have a user state, which is just an array of all the users' names. And then we finally have a state for any error. And the reason we have these three different pieces of state is because inside this useEffect right here, we're doing a fetch request to fetch this data from some type of API. So we're accessing the JSON placeholder API to get all of the different users. And then we're converting those users to JSON and putting them inside of our array. So if everything goes successful, we'll end up with a list of names on the right-hand side of our screen, as you can see here. Now, if there's some type of error though, we want to make sure we catch that, and we're just going to set that specific error. So if any type of error happens, it'll come inside of here. And then finally, at the very end, we want to make sure we set our loading state to false since we finished loading, whether it's an error or our valid data. Now also, to make sure that we don't have multiple fetch requests all happening at the same time, we're making sure we abort fetch request anytime we rerun this component. So we use this controller right here to create an abort controller. We pass along the signal here, and then when we redo our effect here inside of our cleanup, we call controller.abort. All that does is it cancels this entire fetch request and makes sure that none of the rest of our code actually runs. That's actually going to get hit inside this catch, which is why we have this simple check right here to make sure if we've aborted this request, don't actually render an error because we meant to do that and it's not an actual error with our application. So this is a very boilerplate basic way of how you handle fetch requests inside of React. Wrap them inside of a useEffect, store all your state variables, and then make sure that you abort the fetch request anytime you do a re-render of this useEffect, and make sure you save your state variables based on whatever the outcome of your result was. And this works just fine. If we actually come over and we slow down our network speed to see what this looks like, we'll come in here, we'll throttle this down to a slow 4G, and I'll refresh our page, and we'll see briefly that you'll see this loading state show up on our screen before it actually renders out what the actual content of our page is. Now it takes a while to load, but you can see it briefly said loading, but it really was kind of hard to see. So instead, I'm just going to artificially slow down this fetch request drastically by coming into here and just wrapping this inside of a promise. So we'll come in here, let's make a function. We'll call this function wait, and it's going to return a new promise with a resolve. And inside of here, we'll do a set timeout. There we go. It's going to call resolve directly inside of here, and let's make it wait like 2 seconds. There we go. So now I can use this wait function up here. I can say wait.then, and then I could put my entire fetch inside of this. There we go. So essentially, it's just going to force us to wait 2 seconds before we run our fetch request. This should hopefully let us see the slowdown that's happening. So now when we refresh our page, it'll say loading for 2 seconds before it renders out the rest of our code. That all makes perfect sense. And if we have an error, this will also work properly. For example, I'll just come in here, I'll just make sure an error happens. So now when I refresh, it'll say loading for 2 seconds, and then finally error loading the user data. And to get everything to print out, I'm just checking if loading is true, print out loading. If we have an error, print out the error. Otherwise, loop through our users and print each individual user out. So that's basically how our code works. And this is overall, for the most part, perfectly fine. But there's a bit of a problem with our code. And that's that it's not super clear exactly how everything works. For example, what should our page do if our error is true and our loading is true? Or what happens if our loading is false, but we have no data and we have no error? These are states that we should never be able to reach inside of our code, but currently it's possible for us to get those different states because of the way that we have our state being stored. It's just 3 individual state variables, so we can obviously get these in any particular order we want. The error could be there or not, users could be there or not. For example, what happens if we have a user array and we have an error? Obviously, we don't know how we render that particular situation. So this is where when you have more complicated state, especially when you have multiple state variables that kind of interact with each other to do certain things, this is where the idea of a useReducer comes in. And useReducer is just a more complicated way of handling state, which works easier when you have more complex state. So let's take a look at how this works. We have the useReducer function, which we call. And this useReducer function always returns to us an array of data, which is going to be 2 separate things. The first one is going to be our state. So this is all of the state in our application. And the second one is going to be a function which is commonly called dispatch. And this dispatch function allows you to perform different actions on this state. Now inside of our useReducer, we are expected to pass this a few different arguments. The first one is a function. This is commonly called reducer, and oftentimes this function is defined outside your component, which makes the most sense. So we'll define that reducer function just like that. And this reducer function takes two parameters. The first one is going to be your state, whatever your current state is. And the second is whatever action that you want to perform. And we're going to do something inside of here. And in the end, it'll always return to us some new state variable. In our case, we're just going to return the state as is. So that's how we use our useReducer hook. But you'll notice we're still getting an error. And that's because by default, the useReducer hook also needs to take in an initial state value. Just like useState takes in an initial value, useReducer takes in an initial value for our state. So in our case, if we wanted to store our loading, our users, and our error directly inside of here, we could put all of them inside of here. So we could say loading, which is going to be true, our users, which is an empty array, and then our error here, which is just going to be an empty string. That is going to be what our default state for this entire useReducer looks like. And that kind of takes care of all the code down here because now that's all inside this state variable. So I could, for example, say const, and I can get loading, make sure it's an object, loading, users, and error by extrapolating out that state variable. And that gives me each one of these instances of my code. And I can use them all the way down here however I want. So you can see I get all my different information being returned. Now, since we're using TypeScript for this particular application, we need to type everything properly. So I'm going to create a type for our state. We know that our state is just a loading, which is a Boolean. We have our users array, and that's just going to be an array that is a name string, just like that. And then finally, we have our error, which is just a string. So that's our basic state. So we can give that our type right here. And an action is just the different things that you can perform on your actual state. And often your actions are going to be using a discriminated union in TypeScript. It doesn't matter if you know what that is or not, but essentially our action is going to be a bunch of different types of actions that we can do. And they're almost all going to have a type property, which is going to be the type of action that you want to perform. For example, we'll say like start fetch or something like that. And then we're also going to have any type of payload that we pass along with that as well. This would be certain data we need to pass along. So for example, what our users are, or what our error is. In our case, starting the fetch has no extra data being passed along. Another type of action that we may have here is we may have like an error loading action, for example. And this is going to pass along our payload. And the payload is just going to have our error, which is going to be a string. There we go. So now we have these two different types of actions. We can start fetching and we can have an error fetching. We'll change this to error fetching. And then let's just say we have a success fetching, and this payload is going to be our users, which we know is going to be this user type up here. So I'll just copy that over just like that. And now we can use this action type down here, just like that. Now the structure of your action could be literally anything that you want. Oftentimes it's going to have a type property and a payload property, but you can structure it in any way. It does not matter. It's entirely up to you. So this is just a general way that most people do it. But again, like I said, you can do whatever you want. And now once that's done, we have our state variable with all of our proper types. Our dispatch function has all of its proper types, and we can essentially replace all of our state manual updates by calling dispatch. And dispatch just takes one of these different action types to it. So if we come and we try to call dispatch, you'll notice when I call this, you can see it takes an action. So it's going to take a type, for example, start fetch, and then it's going to take anything else. In our case, start fetch has no other data, so it just takes start fetch. And what that does is it's going to call our reducer function, passing in our current state and whatever action we want to perform. So calling dispatch just takes our current state and then this action and passes both of those to our reducer function, which will do some code and return to us a brand new piece of state. So in our case, this dispatch function would be equally easy to place right here. We want to start our fetch at the beginning, so we're saying start fetch. And then we want to update all of our state variables appropriately inside of our reducer function. Oftentimes in these reducers, you're going to be using a switch. So we can do a switch on our action.type. And now we can say, in the case where we have the type, which is going to be start fetch, then we want to run some specific code. And at the bottom, we'll break out of that. And in here, we just want to make sure we return a state variable. So actually, I don't even need to put that break because we're going to return our state variable inside of here. So this is going to return to us our state variable. And often inside of these, you'll take whatever the current state is and spread that out. So we have all of our old state variables, and then we just only replace the ones we want to update. So in our case, we're going to set loading to true. We're going to set error to an empty string, and we're going to set our users to an empty array. Now, since that essentially completely overwrites our state, we don't need to spread out the original one. And we can just say, anytime we try starting a fetch, it's going to replace our state with this brand new value. So now when we call that start fetch, our state will look just like this. And we could do that for all of our different cases. So let's come in here with a brand new case. and this case is going to be for error fetching. Now in this particular case, we again want to return a new object for our state, and this new object for our state is going to have this payload error that we want to set on it. So we can say our loading here is going to be false, and what we want to do is we want to make sure our users is equal to an empty array because we don't have any users, and our error is going to come from our action.payload.error because we know that whenever we have an error fetching, we have this error type on here. Now I can do this exact same thing all the way at the bottom for when we have a success fetching, and this success fetching again is going to take in our users. So we can say action.payload.users, and our error here could just be set to an empty string since we don't have an error. So now essentially I've handled all the different cases. What happens when I start fetching, what happens when I have an error, and what happens when I am successful in my fetching. And I always return in all of those different use cases. Now you'll notice I'm not actually using my existing state for any of these, but sometimes you may want to use that existing state, and oftentimes it is just to do something like this by spreading out that existing state. So if you had some other value that was changed through other means, you would want to make sure you spread that out so it's available in all your other states. But in our case, we don't need that because we're completely updating all of our state variables every single time. So now let's actually go ahead and use that. So anytime we want to do a start fetch, we can do our start fetch. Here we can do a dispatch, and this one is going to be for successful fetching. And we need to pass it along that payload, which has our user's information inside of it. That's going to make sure to handle all of our updating for any user-related stuff. I can do the same exact thing down here for our error fetching. And here I want to pass along an error, which just says error getting users or something along those lines. I don't even need this finally section anymore because all of these dispatches make sure to handle the loading state for me. So I don't have to worry about forgetting to add that loading state in certain places. Just by doing that, you'll notice all the rest of our code stays the same. The only thing that changes is how we save our state and how we update our state. And you'll see here that the code is much simpler because now instead of manually updating each piece's state individually, I have one function I call, so every time I want to start a fetch, I can call start fetch and it updates everything perfectly. Same thing here, whenever I have a success fetching, it updates everything perfectly. And when I refresh my page, you'll notice the behavior on the right-hand side of our screen works exactly the same as it did before. So to kind of briefly go over this again, the important thing to understand is this is only useful when you have more complicated state, and especially state that updates multiple variables at one time. You can see here in every single one of these cases, we're updating 3 separate variables. So when you're updating lots of variables at the same time, a reducer makes a lot of sense. If you only have 1 or 2 state variables and you're only updating them individually, a reducer doesn't make sense. But if you have a lot of intertwined state variables, a reducer is a great option. Now again, to use a reducer, you always pass it a reducer function, which takes in your current state and it takes in whatever action that you want to perform, and you always return a brand new value for what your state is going to be. Secondly, inside of useReducer, you pass it an initial default value, which goes inside of this section right here, and there's also a third parameter that you can pass to it. If you remember inside of useState, you could pass it essentially an initial value, or you could pass it a function that would evaluate to your initial value, which is really great when you only want the code for your initial value to run one single time. useReducer has the exact same thing, but instead you pass that as a third parameter. And this third parameter is a function that takes whatever you pass in as the second parameter and essentially passes that along as the value right here. So in our case, this gets passed along as our value here, and then whatever I return from this, so a new state object, is what gets used for my state variable right here. So essentially, if you have some code that's really slow to execute and you want that to only run one single time, you can put it inside this third section right here. And then in our case, let's say that we wanted to return our value as is, and I wanted to add some like other slow property. I could add on that other slow property inside of this section right here. For the most part though, I don't use the third parameter of useReducer very often, and when I do, I often just don't even pass anything as the second parameter, and I just return my full object here inside the third parameter. So essentially, my third parameter would look like this, where I just return the function like that. This would essentially be how I would use this in a more real world scenario. So if I want to do things in a function instance where it's a little bit slower, I just do everything in there. Otherwise, for the most part, I don't need the function. So I just put my default value right there as my second property and everything works fine. So useReducer is really great when you want to clean up how your state works. But what happens if you want to clean up the logic inside your function? In our case, we have a lot of code inside this function for managing this single fetch request. You can see that all of this code is just there to manage our fetch request. And then the rest of our code, which is quite simple, is for rendering everything to our page. This is where custom hooks come in. When you have a lot of logic inside your component that you want to maybe extract out into somewhere else, you can create a brand new custom hook to do that. So what we're going to do is we're going to create a custom hook which is just a function that starts with use. Anytime you have a custom hook, it must always start with use. That's how React knows it's a hook, and we can call this whatever we want. We can call this, for example, use users, and this is going to be fetching my users for me. And then we can just take all of the code that we had inside of our actual component that we want to extract out, and we can use that somewhere else. So I'm going to take all of the code for our useEffect and our useState. I'm going to put that inside this useUsers functions right here, which is a custom hook. And remember, when it comes to the rules of hooks, you can only use them inside of function components in React, but you can also use them inside of custom hooks as well. So here we have a custom useUsers hook, so we're able to use our own hooks inside of there. So now we have access to our state, as well as this dispatch. We have our full useEffect that handles everything state related in here. And at the end, I just want to return my state variable. So now this useUser hooks encapsulates all the logic for fetching this data. It encapsulates everything for handling my error and success states, handling all the things with canceling my request and so on. All of that is inside this one single function. And all the way up here in my code, I can just call that useUsers function just like any other hook. It follows all the same rules. It works exactly the same. Just now, this custom hook gives me the own data that I want. So for example, here, I can get loading, state, and error because it returns to me an object that contains all of that information. And you can see, actually I called this users, not state. There we go. You can see now everything still works exactly the same, but this app component is much easier to read. This component right here, this custom hook, it gives me my users, and then I use that information to render everything out. And this complicated code for getting my users is all encapsulated in this one hook, so I know everything in here is specifically related to getting my user information. It makes it much easier for me to read my code when I can extract it out into these custom hooks. And that's the whole reason for custom hooks. Essentially, when you have lots of complicated logic that's making your components harder to read, you can move those into a single hook, which you can then use inside of your component to make it a little bit easier to read what's going on and encapsulate your logic in ways that's more maintainable. Now, when it comes to managing state, useReducer is great for more complicated state, but useContext, which is the next hook I want to talk about, is great when you have state that spans multiple different components. Now, to understand why you may want to use that, let's try to simplify our code drastically. We're just going to export a default function called app. And inside this function, we're just going to essentially have a really simple component that just has an input, which is going to have a name. So we'll come in here just like that, and we'll make sure that this is a state variable. And we'll set that equal to a brand new useState. And inside of here, value is equal to name. And we'll say on change, we want to update our name variable to be that name. There we go. So now we just have an input that's going to update its value properly. And we need to make sure that obviously this code for accessing our state is in the same place we have this input. But what happens if we have a bunch of children and one of those children needs access to the name? So let's create a brand new component called child. So we'll come over here, create a brand new file called child.tsx. Export function child, just like that. And I'm going to return inside of here a div, and maybe that div does something, but inside of here, we're going to have a grandchild component, just like that. So essentially, I'm going to just create a brand new file called grandchild.tsx, and let's make sure I spell that properly. There we go. And we'll paste this down, grandchild component, and inside of here is where I want to render out whatever that name property is. Well, to be able to get that, I can pass it in from our props. So we can say we have a name that's a string being passed into our properties. There we go. Now you can see we have no errors in this file, but our child requires us to pass a name to the grandchild. So our child is going to take in a name, and that name is going to be a string. Okay. Now we have no errors inside of this code. At least we will have no errors once I import this component. You can see that removes all of our errors. And now inside of our app, when I import my child, it still requires me to pass a name, so I can pass it in that name. But you'll notice we've done something kind of interesting. This grandchild is the only thing that needs that name, and when I type it out, you can see it's printing that name. But I had to pass the name into our child component here, even though it's never used in this child component. It's just directly passed to the grandchild component. And you can imagine, instead of just having 2 levels of nesting here, I had 50 levels of nesting or 100 levels of nesting. I needed to use this name like 90 levels deep. That would require me to pass it through 90 components that didn't need it, just to get to the one component that actually used it. This is called prop drilling, and it's generally something that you want to avoid. In some instances where you're just passing it through like one level like this for one variable, it's perfectly okay. But as soon as you start passing more and more variables and you start passing them deeper and deeper into your children layers, this is when it becomes a big problem for maintainability and just overall clean code. This is where the idea of context comes in, because context allows you to create essentially a piece of state that can be used anywhere in your application without having to pass it through props like this. So let's talk about how we can set up context. All we need to do inside of our code, instead of using context like this, we don't actually need to use context in our main hook here, our main component. That is going to be what's used in our child component. We'll come in here and we want to say we want to use context. And from there, we'll be able to get our name property from here. But we need to set up our context inside the app. So to do that, we need to create a context, which inside of React, we have a create context function we can import directly from React. And this is going to take in a default value. In our case, we'll set our default value to an empty string because that's what our name will be by default. And we'll call this whatever we want. So we can say const name context is equal to this. And generally, this is going to be something that has a capital letter at the start because we're going to use this as a React component inside of our code. Then what we do with this name context is we wrap all of the code that we want to have access to whatever variables are inside of here. Generally, this is going to be an object with certain variables. So like a name like this is what it's going to look like. So we'll keep it as an object because that's very standard for how to look. So we need to take all the code that we want to have access to these variables and wrap it in that new component. So what I can do is I can say, you know what, all the code inside of here, I want to have access to that. So I'm going to wrap it inside of this name context right here. And then to get the value for this, we just pass along a value prop. And this value prop, in our case, is an object that is the name. So we're just going to pass along whatever this name is right here as our value property. Now, any component inside of this child has access to this name property, no matter how deeply nested it is. So I no longer need to pass name through child. I can get rid of the name here and the name here. You can see it's not being passed through. And here I can get rid of all of this name related stuff here. And instead, in my use context, I just need to pass it our context, which we called name context. So in our app, let's make sure we export this so I can use it. And we'll come into here and we'll say that I want to use that name context. And now if I save all of these different files and I make sure, since this actually returns to me an object, that I destructure that object, my code now works exactly the same as it did before. So to get a little bit better idea of what is happening with our code, we essentially wrap this name context around all the things that we want to have access to this context. And now any component inside of here, or a children, doesn't matter how many levels deep it is, as long as it's wrapped in this name context anywhere, that means inside of those components, we can call useContext and pass it that context itself, and it's going to return to us whatever that context value is. In our case, it'll return to us an object with the name property. So whatever this value is, we get access to that immediately inside of any of these children that we want to. So we can use it, 2 levels deep, 10 levels deep, it doesn't matter. And this gives us a ton of flexibility because we now no longer need to pass these values all over the place. This is really great for things that are generally more global. For example, like a theme variable for your entire site. Context is a great place for that because you can put it in one variable, and then all the components that need access to that theme variable can get it, and the ones that don't can just pretend it doesn't even exist at all. And the great thing about context is, since it works just like state, like it uses state to be able to render its values, when this component re-renders, it's going to get a brand new value for our value here. So it's going to give us a new value inside of our context, which then allows us to update this component automatically anytime that value changes. So since it's all tied back to state, which does this re-rendering for us, we don't have to worry about re-renders or anything like that. Also, you may notice that this name context actually gives us an error. Fast refresh only works when a file exports only components. Move your React context to a separate file. This is something that's optional if you want to do. Essentially, this fast refresh thing allows you to, whenever I change my code inside this file and save, it automatically quickly refreshes my page without refreshing all my state and everything like that. So we could move this to its own file if we wanted to do that. So I can come in here and I could just say context.ts, and then I could paste that down just like that. Make sure I import my create context. And now inside of here, I could import that name context just to clean up that fast refresh error if I wanted to. And inside of here, I would need to do the exact same thing, import this from that new location. And now we can see, hopefully if we refresh our page and I change my state, it works just fine. And also if I were to change my code inside of here and it refreshes my app, you'll notice it doesn't delete out my state variables. So that's what that warning or error is. Technically, you don't have to do that. It only affects you during development, but it's nice because it makes your development life a little bit easier. Another really common use case for a custom hook is with context. For example, we know that if we want to get the name context, we need to call useContext and pass it in the name context. Well, to make this a little easier, you can actually create a custom hook called useNameContext. You call it whatever you want. It just has to start with that use keyword. And then inside of here, we can just return calling useContext with the correct name context, just like that. Now inside of here, I can call useNameContext. and make sure that I export that from here so I can use it in other places. There we go. Use name context. And now it just makes it a little bit easier to use this code because I don't need to manually reference my context itself. It just knows what that value is. And if we look over here, you can see everything still works the same as before. So it's a very common use case for a custom hook. Now to clean us back up, let's get rid of this child component, context, grandchild, and we can get rid of all of that from here as well. There we go. So we're now just back to a really basic input component itself. And I want to talk about the next hook, which is the useRef hook. And this is a very interesting hook. We've talked about the useState hook, where every single time that you call your useState hook, it's going to re-render your component with a brand new piece of state. So every time your state changes, your entire component re-renders. Well, useRef allows you to store data, but this data does not cause your component to re-render when it changes. So it works very similar to useState in that we pass it an initial value. It must always be a value. So let's say that we pass it in here a value of Kyle, or just like that. And then over here, I can say const name, or I'm going to say my name is equal to this useRef hook. So now I have this my name variable that is set to the value of Kyle. And if I were to try to use my name, you'll notice it actually has this property called current. So it gives us an object with a current property, and this current property just gives us whatever the most up-to-date value of my name is. And I can just change it directly by just saying my name is now going to be Sally, and that updates the my name variable to Sally. So the next time I access my name.current, it's going to be equal to Sally instead of Kyle. Now to really hammer home exactly what's working inside of here, by default, I'm going to set this to 0, and I'm just going to set this to a variable called number. And then I'm going to create a button on our page. And this is just going to be called random, just like that. And this is going to give us a completely random number every time we click on it. So when we click on it, I want to take my number.current value, and I want to set it to math.random. So every single time I click this button, it's going to give me a random number, and it's going to then use that number somewhere. For example, let's just put our number right here in our component, and we need to make sure we get the current value from it. There we go. So now you can see my number 0 is being printed here. But you'll notice when I click random, it doesn't matter how many times I click it, this value never changes. And that's because when you change the value of a ref, it does not re-render your component. It updates that value behind the scenes, and the value for my number is the correct value, but it doesn't actually re-render that to my page because useRef never re-renders your component. We can actually see this relatively easily by creating a brand new button. We'll just call this one print. And inside of this one, all I want to do is I want to say console.log number.current. So now when I click print, it's going to log out whatever my current number is. So let's refresh our page real quick. I'm going to randomize my number, click print, and you can see we get a random number. If I click random again and I click print, again, a brand new random number. Every single time that I click random, I get a brand new random number. And also you'll notice when I change my state, which causes my component to re-render, now it's going to render out that number value with whatever the current value is. So ref is really great when you want to store values inside your component that are tied to your specific component, but that don't actually cause your page to re-render. Because normally you may think, well, why don't I just put my number variable out here? I could say number is equal to 0, and then I don't need this thing right here, and I can update my number properly in all of these different locations. And this will essentially do the exact same thing for the most part. Let me make sure this is a let variable. There we go. You can see here when I click random, it gives me a random number, but it doesn't re-render. And when I click print, you can see it prints me a random number every single time that's different. And when I change my state, it updates this value right here. The problem with this approach, though, is that this number variable is shared across your entire application. So every time you render an app component, they're all using the same exact number variable. When I go back to when I was using refs instead, each individual instance of my app component, so every single app component, has their own random number that's entirely different from all the others. So this is tied to my app, but it doesn't cause my app to re-render. So that's one use case for the useRef hook. The other use case, which is by far the most common way of using it, is referencing elements on your page. So in our case, I want this to reference my input element down here. So we're going to call this input ref, just like that. And by default, we don't have any value that we're going to pass to it. So we're just going to pass it a value of null. And we can get that input ref by passing it as a ref prop to any element inside of React. So every single React element has this ref prop on it, which allows you to essentially pass it a specific ref from useRef, and that's going to set that ref element to whatever that input element or whatever is. So by passing along a ref to an element, that value gets passed along here. So now I have access to that specific element. And to make sure this is typed properly, I'm going to say this is an HTML input element, just like that. That's specifically only because of TypeScript. So now you can see this is either an HTML input element or null. So now what I can do inside my code is I could just have a simple use effect that inside here is going to console log my input ref.current. And let's just do that. Now when I come in here and I inspect my page, and we just clear out of everything and refresh, you'll notice it just prints out whatever my input value is, and it's printing that every single time I change, so you can see it's getting the updated value property every single time I re-render my page. So you can see by doing this with the ref, I now have access to the raw HTML element, which can be useful for certain things. Like if I want to automatically focus this element, I can just come in here and I can say that I want to focus this the very first time that my page is rendered. And now if I refresh my page, it automatically focuses me inside of that input. Now this is actually a very common thing, which is why React has an autofocus property that you can use. It does the exact same thing. So when I refresh, you can see it autofocuses, but this is essentially being used just to showcase how this particular thing works. So if you want to be able to get a raw HTML element reference, you want to be able to pass a ref to whatever element that is, and that's going to give you that ref right here. The important thing to note though is that this ref only populates its value after your component renders, which is why I'm using it in a useEffect here. If I were to console.log what my input ref.current is equal to here before anything actually happens, and I inspect my page and we just go here, clear this out, and I refresh, you notice it prints out null, because essentially the way my code works is it runs top to bottom. So here I create an input ref, set the value to null. I then access that value, it's still null. And then finally I update that value, but I've already accessed it up here. So I already accessed it while it was null. That's why when you use these input refs, they're generally going to be either tied to button event listeners or they're going to be tied to a useEffect. Now, while we're on the concept of useEffect, I want to talk about another hook called useLayoutEffect and really explain the differences between the two. Normally when you have a useEffect, this useEffect is going to run after everything inside your component happens. So your entire component is going to run, all of your HTML is going to render and show up on your screen, and then the code in your useEffect is going to run. For 99.9% of use cases, this is perfectly fine. But the problem comes in when you actually want to change the position or change something visually on your page before it actually gets painted to the page. Because what happens with useEffect is your entire page gets rendered and then the code inside of here runs. So if this code changes things visually, you want to make sure that that happens immediately instead of showing like a flash of content where it shows it in one place and then updates the place of where that thing is supposed to be after the fact. This is where useLayoutEffect comes in. It has the exact same type as the useEffect where it takes in a function and it takes in a dependency array. Everything about it works exactly the same. The only difference is when useLayoutEffect works. useEffect, like I said, happens at the very end after everything shows up on your page. useLayoutEffect runs right before your page is actually printed out to the screen. So it runs all your code inside of here, figures out all of your HTML, what it's supposed to look like and so on, and then our useLayoutEffect runs, figures out any last minute changes before rendering the content on your page. Because of this, useLayoutEffect is a little less performant because this has to finish running before your page can render, so it's always recommended to use the useEffect hook by default. But if you need to be able to change something visually before it shows up on the screen, this is where useLayoutEffect comes in. Now, a great example of this would be a tooltip. So let's create a div here that just says tooltip inside of it. And I actually have a class, which is called tooltip, that we can add to this. You can see we get this tooltip positioned absolutely on our screen. In my case, I want this to show up below my input element itself, not on top of it. So we can use a useLayoutEffect to make sure that this goes in the right place. So let's come in here, we'll just say tooltip Y, and this is going to be my tooltip Y position. So we can say tooltip Y, set tooltip Y. That's going to be equal to useState. And by default, let's just say we set it to 0. So here inside my style, I can say that my top is going to be set to my tooltip Y. There we go. So by default, it's going to be set to 0. And we should probably put this as a pixel value. So we could say 0 pixels just like that. Now I want to update this to be the correct location. So in my useLayoutEffect, whenever I mount my component for the very first time, what I'm going to do is I'm going to get my input ref. So we can say input ref.current. If this is our value here, then I want to get the content rect. So we can say rect just like that. That's going to give our, not that one, sorry. Dot get bounding client rect. There we go. That's going to give me this rectangle around this. And then that's going to be our box. So we'll just say box. And then what I want to do is I want to say set tooltip Y equal to my box.bottom. That's just going to give me the bottom of my box. And for some reason, if this is null, for example, my input ref doesn't exist, well, we'll just default this to 0, but that should not actually happen. And make sure that's 0 pixels. There we go. And this should also be changed to a pixel value. So here, just like that, and this should say pixels, and this is where I'll default that to 0. There we go. So essentially what happens is either set to 0 pixels, which shouldn't happen, or it's going to be set to whatever the bottom of my container is. When I save, you can see that tooltip does go to the correct location, just like I would expect it to. but there's a little bit of a problem if we use useEffect, because useLayoutEffect runs before everything is rendered to the page, so it's obviously moved to the correct location. But if I change this to a useEffect, you'll actually notice something interesting if I refresh my page and I make sure that I import useEffect at the top of my page, just like that. Now, if I refresh my page, there's a brief instance where you can see that tooltip is actually rendered at the very top of my screen up here before it gets moved down below. And that's again because this happens after my page renders. So my entire page renders, my tooltip position is set to 0, and then when it's done rendering, it updates the tooltip position and moves it down. This is why if you want to be able to paint something to the screen in a specific spot or move something, useLayoutEffect is what you want, because you can see when I refresh, it always stays at the bottom. It never flashes at the top. For the most part though, you should be using useEffect by default because it's more performant, happening after the paint since your page doesn't have to wait for it. But in those rare instances where you need something like useLayoutEffect, you're going to want to use this for those instances so you don't get that weird flicker effect.